of what is harder and what's softer, or what absorbed sound better, what scattered sound better, versus what reflected it better.
Gotcha.
So that's backscatter, and we can overlay that on the bathymetry. Geologists really like that. Yeah, I think that's it.
Black magic.
Black
Backscatter.
Black magic. Yeah, I never had that explained to me before. Thank you.
Sure.
A question coming in about why the rocks all seem to be kind of running parallel to. Is that just because of the?
That's a good question.
That has to do with the speed, our ping rate and our speed. So we're going slower than the side scan can kind of deal with. So it's kind of it's the waterfall, which is what we call this display view that we're looking at. It's moving quicker than the speed of
Argus.
Of Argus.
So it's stretching it out.
So it's stretching it out. We're probably seeing the same rock that's being elongated. That's why we're when we talk about being wary of things that are straight in that direction. Yeah, that's kind of. But that can be fixed in post-processing. It accounts for the speed, and it kind of squinches that up.
Have we seen any of the post-processing product yet?
Sorry.
I have not. I know Mike's dealing with that, so I'm not sure how.
That's why we haven't seen Mike.
Yeah, not sure how much is correcting it.
We're getting close to that funny tall target.
We are, yeah, and actually we should be seeing number 8 in our on our port side, hopefully soon. It'll be just at the edge though, so we may not. Ed, this is where you tell me I was off SPL for all of
I was so like holding back because you told me you did that to you once. And
What'd you say, Rennie?
You been talking over there?
Something about sonar.
Yeah.
It's a little ridge of
I like the rock concert analogy.
yeah, that was
Yeah.
That was a
Good
good one.
one.
I didn't know that
Jinx.
about the speakers until I learned about beamforming from multibeam.
If you're in a concert in a indoor venue, that column will actually be curved, and that's so that you get the sound up in the balcony as well as down on the floor. And just saying, there's a fantastic New York Times article, probably 6 weeks old now, about how modern concerts have great sound due in large part to pioneering work by the Grateful Dead.
Yes, I was going to reference the Grateful Dead.
Yeah.
Both in microphone technology
And the wall of sound.
and the speakers.
why they were like the first to experiment with.
They're the
all
first to
that?
have the resources and the care enough to improve the sound, and the advancements they made really led to a lot of the technology that's used nowadays. I mean, it's very sophisticated now. Venues are tuned using white noise to correct for the anomalous acoustics of a concert before you ever show up. The engineers play white noise through there.
Really?
And then the towers at outdoor venues that are back, they are delivering audio that is delayed, so the audio from the stage is hitting you at the same time as the audio from the tower, so you don't get a reverb. And there are sensors throughout the venue that tell them heat and humidity, because that affects the speed of sound through air, and that changes over time. So when they set up the venue, there's nobody in there.
Yeah.
And then when you have all these people, sun comes out, sun comes down, etc.
Yeah.
So they adjust for that.
Wow.
And that's something that, relating it back to multibeam, we have to do all the time, is the speed of sound through water is not constant. It's going to depend on depth, temperature, and salinity.
And it's nowhere near linear.
Yeah, it's not linear. If it was just depth, there would, it's just like
You could work that out.
Yeah, you could work it out, but it's more than that. So obviously the temperature of the surface of the water is changing. That's mainly, it's what we can model a bit as we get deeper, because temperature we can model a bit better at depth, salinity same, and
But at the
but at the surface, there's a lot of temperature change diurnally, regionally, depending on currents, everything. So even within an individual multi-beam survey, we're constantly taking measurements of the conductivity and therefore salinity, the temperature and depth, and getting our sound velocity profile of the entire water column to understand how sound travels through the water column, to know how it's when we receive it, what kind of medium it's traveled through, and how it's reflected and refracted on the way back.
Thermocline layers can be pretty severe changes in short distance and pretty thin too. So submarines will use those thermoclines to hide.
A question coming in about sight-scan sonar and marine mammals. That if it's something that.
So
That's a good question.
anything involving sound in the water, it's going to depend on the frequency you're using, whether or not marine mammals can hear it, the duration of how long you're in an area, and the volume that you're emitting it at. So with our side-scan sonar at depth, the frequency that it's emitting, it's not really too much of a worry. Some of the big oil and gas operations using seafloor penetrating sub-bottom, very loud to get a lot of layers. Yeah, there's some concern there, but it really, it's like I said, it's going to depend on how long you're operating in an area. If it's not damaging, let's say if it's an annoyance, is what you're gaining, with the knowledge you're gaining about the environment, worth the annoyance? Obviously, that's different from damage, so you kind of have to, and there's protocols we have as far as slowly, if we're operating our multi-beam system, slowly ramping up the volume in an area to kind of say, if you're in this area, go away if this is bothering you. Also, marine mammal watches, kind of having the bridge let us know if there's marine mammals in the area, if we're super shallow. Did I mention that depth? Yeah, so depth also matters. So if you're
flashlight on the wall.
Yeah, if you're super deep, then you can afford to be louder, versus you wouldn't want to use that same amplitude in shallow water. You'd be blasting out anything in the area. So it takes some knowledge of the system, and some good practices as well.
Nice.
So an add-on to that, though, we can actually see fish and mammals presumably in the sonar as well sometimes, right?
Yeah, I don't know. I haven't ever seen a marine mammal in side-scan sonar,
Right.
but I imagine you could, certainly if it was there. Yeah. And some of it is, it's less about is it bothering them, but there's also a concern of is it changing behavior. Sometimes I think, we've got, we'll have dolphins up next to the ship hanging out with us, whether we have the multi-beam on or off. But the question is it...
I'm going to go ahead and mark this.
Sure.
Yeah.
This will be target 50?
60 to port.
Yep.
Huh.
Time is 11:44.
Ding.
I'm sorry, what was the target name? I missed that.
50.
50.
Gotcha.
Yes.
That could be, it's close enough to our funding tall target to be the same, but it's hard to say.
Oh, okay.
But it is unique looking.
Yeah.
What did the funny tall target original image look like?
We didn't take it.
Oh.
That sounds like the beginning of a riddle.
Yeah.
In an airplane.
Did the funny tall target have incandescent bulbs?
We kind of let that one die. Last night we were just about 4 minutes into the watch before we referenced that. Now we're 45 minutes in, so a couple more days and we'll be done with that joke.
Description.
Don't count on it.
Description possibly funny tall target. Several humps
No, you don't have
with
to mention it.
centered. Oh, okay. All right. I'll just erase that.
I just like this,
Yeah.
the lineage in there.
Yeah, striations within the highlight.
Hey, I'm glad that you said striations instead of lineage.
Ooh.
Yeah, I feel like when we do this science stuff too, Peyton's gonna be talking a lot more in the next weeks. We don't have time for
Yeah.
riddles.
I will also have
Are
a
you
lot
done
more to
with
do.
the-
Yeah, striations within
We will
highlight.
illustrate
multiple
everything.
shadows. I'm done.
Okay, thank you.
Oh, come on, you got to talk about the difference now.
What's that?
I can't even say those two words. The difference between,
Striation?
yeah,
Striation and
and the other one.
What was the other one?
Lineage.
I think that
Okay.
lineage
One's
is
real.
basically not a word.
One is-
Lineage is something that liberal arts majors use to describe
Yeah.
scientific terms.
somebody who mispronounced lineage.
Definitely not what I was going for.
Ooh.
Nudie.
That's my-
All right, done.
152 now.
152 holothurians noted. So since we've been counting.
Here's a news flash.
Maybe some
Only
scientists
2 of the
want to-
3 watches are counting up now.
Yeah.
Oh,
Maybe
I
some
have to-
scientist wants this data that's into
Yeah, maybe I have to go back through
Should
all of
probably-
the footage for our dive report.
I hear Peyton volunteering. Just saying.
Oh no.
You don't have any summer plans, right?
On the
Apparently
last
not.
cruise, we were, we had to have Argus down so the blue water could be recorded so they could count the whatever critters were going through on the ascent, descent.
That's all you guys did? Was go down and then come back up?
Well, it seemed like that's all we did for
Oh.
days, but we were like the valet shift.
Yeah, that was.
So we're closing in on our next line. We've got 5 left, correct? 16? There's 20 total?
Let me double check that. 4 definitely, and we'll see if we want to extend. Yeah, 5.
Okay.
5. We'll see how we want to.
What'll that take us into, do you
Like
think?
15
Ballpark.
hours-ish?
With the corners too?
Yeah, with the turns.
Maybe longer than that. It's gonna. It depends on the kind of speed we're making. Has really been it.
What are the winds down to 7 or something?
Right
up
now
to
they're
12.
12, but
Yeah.
Or just in the trough,
yeah, this heading is kind of exactly
killing me.
the wrong heading. But
What direction are the winds?
the winds are coming from the northeast.
Because it's interesting to note that on the day of the accident, in the morning the winds were from the northeast until 3 in the afternoon when they changed to the west, and then 8 at night to the southwest, and the next morning during the search the winds were northwest, then changing to southeast,
It's a lot of change. We've pretty much been
or southwest, sorry, changing to the southwest.
Yeah, since we've been out here, it's been mostly coming from the east or northeast. Same, I want to say, with the swells been coming from the northeast, or sorry, the east-northeast.
Is there any notation on what the seas were at the time?
Moderate.
Moderate. So it's possible there was lots of debris floating around that couldn't be seen and then was scattered to the 4 points as the wind walked around the compass.
They had the aircraft that Grumman duck that was able to search the area.
All right. At moderate seas, that would have been 2 to 3 meter seas.
Moderate swells.
Yeah. Depends on what they
Hard
define
to see,
moderate
yeah.
as,
But the wind kept shifting around. It seems in the mornings it's from the north, northeast or northwest. In the afternoon shifts from the south.
The doors that washed up, were they on American Samoa? Were they washed up?
No, it was on an island directly to the east of here.
Wow.
Tutuila, right?
Except American Samoa is made up of about 5 islands. Do we know it wasn't American Samoa?
Oh.
I'm not sure.
Sorry.
Yeah, sorry. I don't know my American Samoan islands, but
Where's the map?
Swains, Tutuila, is Rose part of? Or am I mistaken?
Found on Ofu Island in the Manua group.
That's
Manua
it.
group.
Yeah,
80 miles due east of the suspected crash site.
Huh.
that's it.
Due
80
east.
miles.
80
Yeah, it was
miles due east.
East.
And how many hours or days was that found?
11 days.
11 days later, found due east. Huh.
How
Icebox doors from the Samoan Clippers galley have been discovered washed up on a beach at Ofu Island in the Manua group, 80 miles due east.
we're too far south now to get any of that equatorial undercurrent, aren't we?
Yeah. Well, on paper, we would be, if we did get that, it wouldn't, I don't think it would be caused.
But the radiogram
For the
at the
same
time
reason.
noted that the current was uncertain and not well known.
Ocean currents are tricky.
Greetings to our people watching from the Ukraine and Turkey.
Merhaba to Turkey.
I should have known you knew the language. If you have any more questions, please continue to send them in. If you are waiting for some of our future dives or want to know about some of our future dives, you can follow us on social media at EV Nautilus. You can also check out our newsletter, sign up, and you can get all sorts of information that way. And Nautilus also has free educational resources that you can log in to use for our teachers and lifelong learners out there.
Yeah, with the warming water in the Gulf Stream, like that takes the water from Florida all the way up to like Newfoundland and then to Europe. Like, what effect is that having on like the Gulf Stream? I mean, it's getting a lot warmer. I'm assuming that would change some kind of aspect of something.
Definitely changing.
Like the migratory thing of the fish and yeah.
As your professor, I'm going to suggest that your hypothesis needs a little bit more work.
Yeah. Yeah. That's what you get when you have the operations ROV try to talk science and speculate about stuff.
Let's talk about the winch.
Yeah.
This traction winch
Yeah.
is super impressive.
Yeah, how does that work?
Tons of grease, tons of oil, shivs.
What I think is incredible is I forget what even the name of it is, but basically how it doesn't get all tangled up. How it has the slip rings, is that what they call it? Yeah.
What
So,
does it
yeah.
get tangled up?
So you can have a fixed point supplying, or that has the power and fiber optics, but it's also
Oh yeah, the
spinning
slip ring.
around a slip ring.
Yeah, the slip ring, accurate. Yeah, that's a pretty impressive piece of machinery. I actually went to a boat show and I saw one like they had, you know, sliced it open so you could see the inside of it. And it was just like, what? Very complex looking.
Yeah.
And it just, yeah.
Slip ring?
Yeah.
Oh yeah, when I went to school on the satellite dish, it uses a slip ring too, so it can turn
go full, yeah.
It's,
infinitely. Yeah.
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 Or yeah, like
Yeah, they're great fun when you flood them on your TMS and you have to rip them apart on the ROV workbench and
Sounds terrible.
breathe life back into them to get 3,000 volts through them. Again.
That's the inside of one.
Yeah.
oh wait, you have a picture of the inside?
Sliced open.
Yeah, if you're
Awful
listening, what we're
slippery.
talking
Pretty
about is
fast.
how the winch is spinning around the drum that all the cable is on, is spinning around, and eventually that has to be connected to something that isn't spinning around so we can talk to the vehicles and send power to the vehicles. So there's this little magic tube
It is
called
a
a
magic tube.
slip ring, and inside there's
Wizards.
there's little wizards that are
Leprechauns.
allowing those connections to happen without getting tangled up. It's not like, I don't know. In execution, I think it's way more complicated than the theory of how it's happening. But
Yeah.
You could almost buy a brand new Dodge 3/4 ton for what one of those gets you.
really,
Yeah, the Wizards' day rates are real high.
it's a flat fee.
With the Lucky
Never seen
Charm
one
somewhere
opened
hidden
up.
in there.
That's really cool.
I'm like looking at pictures of side scan sonar online, and it makes it look so easy, you guys.
Well, yeah, because they're showing you like, here's a shipwreck. You know, that's what
Yeah.
you're seeing.
Those are pictures from the catalog. It's like
Mhm.
buying a tent. It's a little different when you're setting it up.
That's awesome. Does this have fiber in it too, somewhere?
Yeah.
So,
It might be the
What
same
is that?
manufacturer that the one we have. It's I think it's Moog or
I
Focal.
recently went through that
What's the
with
fiber?
The fiber's the yellow
lawn camping.
the yellow lines coming in on the right.
Yeah, but okay. Oh yeah, over here. Sorry,
Yeah.
I was all the way over there.
The optical pass.
Yeah.
Yeah, fiber optics are it's such a cool technology. It's very impressive. Somebody came up with, well, if we put a bunch of pieces of glass and reflect them in a certain way and shoot a light through it,
Filled with fluid.
we could talk to other things.
We had great fun with those on, there was a batch of several dozen of them one year, and there was some contamination in the optical fluid in the slip ring. And we used one of those on our tether management system,
In
which
the fluid.
gets run down to depth.
Fluid?
Yeah, that picture you have there of the slip ring in the fiber optic pass, there's some mirrors in there that
Oil or something?
that pass the optical signal,
Mm.
and it's filled with fluid. It's filled with an optical fluid to help couple the signal, so it doesn't cloud up or it's basically compensated. Anyways, the combination of depth, the pressure at depth, and the temperature would cause the optical fluid to become cloudy. So we would slowly lose, the light level would attenuate over about a half an hour to a 1 hour period.
Huh.
So basically we would lose telemetry to the vehicle.
Oh, this is, you have it on your, when you have a,
TMS.
yeah, you're connected and
Yeah, the tether management
tether
system.
management system. You've
Yeah, it
got a
has a-
slip ring right on it. and
Yeah, it has
it's-
that same slip ring that's on our winch is actually stainless steel, and it can go subsea. So you fill the high voltage side with
What's it rated
mineral
for?
oil.
Oh, well, I guess if you're filling it, then.
They're usually 3,000 meter rated. The limiting factor is the optical fluid filled bit. The rest is just hooked to a compensator, so it can experience whatever. But it was driving us crazy for weeks. Several systems in the fleet were affected. You would bring the whole mess back up on deck, and the system would be dead, no communication. And after about half an hour, everything would work perfectly.
So the fouling was in the liquid itself?
Yeah, it turned out there was some slight contamination of the fluid when they were manufactured, and that was causing the attenuation.
That must have been a lot of troubleshooting before you got into the fluid and realized that was the problem.
We never figured it out, but they're not really
okay.
like easy things to change. It's
Yeah.
about a 6-hour, and the ones on the TMS, because they're oily, so all the J boxes, you got to open the oily J boxes and drain everything, both sides. And the one in the drum, the rotating J box, is usually fun because it's not real accessible. It's difficult to bleed and get all the air out, full of oil.
All right.
I think our record was changing the thing, I don't know, at least half a dozen times within as many days.
Ugh.
The manufacturer finally figured it out and sent us refurbished ones with.
I guess if enough people call in about the same problem, they start thinking.
Yeah, the slip ring was like the last thing we suspected. We thought it was something to do with the telemetry system, or we had a lot of different theories, but finally we jumpered the slip ring out of the system, and obviously we couldn't come out of the TMS and turn what's basically an underwater winch, but we just put the thing down to depth, and the problem wasn't there.
Right.
It was with the slip ring jumpered out. It was pretty much the smoking gun at that point.
So why is this traction winch so much better than our previous?
The other winch we had was just kind of directly would go straight over the back of the A-frame of the Shiv to Argus, and it was just kind of feeling the heave of Argus at certain points, obviously depending on the depth. But so for every wrap, you know, we have over 3,000 meters of cable on there, obviously.
Yeah, we
4,000?
currently have, I think, a little over
4,500 something. So it's a lot of weight on the drum, and over every layer, you know, the first couple of layers on the drum get a certain amount of pressure, and then the outer ones get less and less, and then over time when you're
12,000 pounds would be on that layer.
Yeah.
If that was a direct.
On
right.
Yeah.
Attention.
Yeah, so over time the cable is seeing different like weights on it at different wraps, and that kind of puts a lot of, I guess, tension on certain parts that it's all uneven, right? So basically what a traction winch does is it keeps the tension throughout the entire cable equal. So it's always seeing, each wrap layer is seeing the same tension throughout any depth that you're diving at. And so you're never having the problem of a cable having to, like, if insulation gets broken through because it's too much weight on that part of the cable. And it's less, I guess, it's more gentle on the cable in a way, in my layman's terms.
It works.
So there's, I don't know how many on this winch. We see a 4 there, and you're just peeking at the number behind there that's painted on there?
Yeah, there's a 4.
I don't know which way they went with the numbers. But there's, so for example, there's probably 8 layers on the drum as you wind it on, and the inner layers get, so this layer, if it was direct drive, right now the tension on the wire is 10,000 pounds. So as you wind that on there, that whole layer is wound on at a tension of 10,000 pounds. That's due to the weight of the wire that's hanging over the back of the ship. And the next layer would be a little less, say 8,000 pounds. So they actually have a spreadsheet when they're putting the new cable on, and they figure out if that wire was hanging over the back of the ship, what the weight would be. So they have a winch that, a wind-on winch that keeps that back pressure, so it's spooled on at the simulated what it would be hanging over the back of the ship. And I think what was happening with on Nautilus is that with that 6/8 wire, it was crushing the, there's a stainless steel tube that the fiber optic wires run through, fiber optic cable runs through, and that was getting crushed, I believe.
Yeah, I think it got, it sounds like it got crushed and it kind of went through the insulation that separates it from one of the coppers. So you've got,
Were they having ground fault
yeah.
issues with it? Yeah.
And then so it basically there's all layers of insulation separating, yeah, all the conductors and the fibers and that K-tube. And so with the pressure of that specific part of the cable, it crushed it enough so it bit through the insulation, and then the conductor touched the K-tubes. So you've got metal touching metal where electrons shouldn't go, and we got a ground fault and shorted.
The smoke got out.
Yeah, the wizards were upset. And it had to, yeah, so it was closer to the, it ended up being on the one of the closer layers to the drum, inner layers, yeah. So we had to re-terminate from the winch end, which was not as fun as
painful.
re-terminating from the vehicle ends. So we had to cut a bunch of cable off, and then we used the traction winch, because this is when we had the old winch on. We used a traction winch at Scripps University. They had one that we could spool ours on, and we spooled it back. We spooled it off, cut the bad cables, spooled that cable onto another drum, and then re-spooled ours on with the traction winch, so we felt that same pressure like we're seeing now throughout the entire drum.
Yeah, it's spooled on under tension.
Yeah.
Same as it is when you're picking it up off the back of the ship. So that particular storage winch has about 2,000 pounds on it for every layer instead of 12,000 pounds on the inner layer. Which if it sits there for months and months with that kind of tension on the inner wires, could be harder on the cable.
Are these cables, with kind of all the stress that they're put on holding Hercules and Argus, do they last like a certain amount of time? Do they have to be like replaced every year or 5 years, or?
It depends on how kind you are to your cable, but it should last for a decade, this cable. But with the two-body system, there's advantage and disadvantage to that. With a commercial two-wire, two-body system, the tether management system and the ROV are free to spin as you ascend and descend through the water column, so that torque balance in the cable is naturally relaxed. So if you had wound up a ball of rope and dangled it, it would unwind itself. In the case of Nautilus, the Argus is always on the same heading when it's launched and recovered, so the torque of the cable winds up at the end in Argus, which will eventually cause some issues. But they, one way to alleviate that with a new cable, they put a weight on it and let it spin out at depth, so the cable's then torque balanced. So as long as you keep it lubricated and don't tangle it up or drag it around on the seabed, it should last for years and years. Some of the other kids have a harder time, like a Jason single body system because it's dynamic and they have floats on it. Winds up getting basically damaged, and you cut 100 meters or so off every time that happens. So your cable gets shorter and shorter, and pretty soon you can't reach your rated depth because you don't have enough string on the drum.
Yeah, you always start out ordering way more than you need because you know you're going to be chopping off a good amount, and it's not cheap. So.
Yeah, I think we're getting 7,500 meters.
With the next.
So Argus is going over our selected targets here. It may be just the way it was kiting in the water. It's a bit off from them, but we still might pick them up. I haven't seen anything promising in the side scan, one way or the other. We should go directly over the target that was selected from sonar, from the edge tech, but not over the targets that were dropped here.
Oh, do we
So
have
that
high
could
hopes?
be in our
High hopes?
outer port side, that could be one of the targets.
Always have high hopes.
This is number 30 you're talking about? 30, 31?
We have a new cable on order, do we, Ed? We have a 7,500 meter cable on order.
WEOET?
Yeah.
We've tried to purchase it twice, but we've been having some issues with the manufacturing. It's never passed acceptance testing, so we're working on some issues.
Same design or different design?
It's not very confidence inspiring.
K-tube.
It's a long lead time item.
Yeah.
Can't go to your offshore 7-Eleven and get one of those.
No.
Not like the Kongsbergs.
Those can be a little spendy. You're not going to go fund me 7,500 meters of 6/8 cable, K-tube. I think they're re-examining the design based on input from our colleagues at Woods Hole. I'm not sure they're as big a fan of that design as they used to be.
Yeah, so if you're listening, it's something as benign as a cable and a winch. It seems like, you know, why are you spending so much thought and effort towards that? That's really like, there's so many elements of the operation that are either single points of failure or, you know, they matter so much. Like if something were to happen to the crane on the back deck, for example, we can't launch the vehicle. If something happens to the cable, you know, or the winch, if some, you know, there's so many, or the ship's dynamic positioning system being able to hold station, you can't dive then either. It's, unless you live boat it. There's a lot of, yeah, a lot of systems that are interacting with each other to allow us to do the kind of work we do.
As Neil Armstrong said, there's a lot of things that have to go right.
Yeah.
And we travel with a lot of spare parts.
Just a couple days away from commemorating the 50th anniversary of man walking on the moon. And similar pioneering spirit as these guys were flying this aircraft across the Pacific. Sounds like they kind of took their own maintenance people with them too. They weren't like
Can we proceed to the selected target?
Lonnie, do you know anything about that?
Thank you.
Say again?
So the maintenance personnel for the Samoan Clipper flew with the aircraft? I don't think they had them staged throughout the Pacific.
Engineer. Yeah, they had engineer board and the assistant engineer.
So those were the
mechanics.
So those were the only people doing maintenance on it?
No, actually, they would have overnight maintenance at their bases wherever they landed, and that was a pretty thorough check of all the fluids and systems, engines, fuel, the whole thing. But Music himself didn't have the same confidence in the base operations for maintenance as he did for home base. He was a bit skeptical about changing parts and so forth. But there was overnight maintenance at every spot. Maintenance actually consisted of routine servicing procedures
Okay.
at stated intervals.
So you're going to have him move over to the southwest? Okay. Roger.
So en route, the overnight airplane
Surprised we didn't
service
see any of those targets.
inspected the vital parts, fuel, oil, water, auxiliary fluids. And the overnight engine service had detailed inspection of the engines, controls, and installations.
So that, yeah,
Oh.
that could be one of the targets.
Yeah, I'm looking up the descriptions for them right now. One of them is 3 rounded objects, the other is blocky with 4 rectangular shapes.
That could be the, yeah.
3 blocky, okay, probably 30.
Let's see if we're getting any more of it in the background there.
Alright, 1 sec.
Yeah.
This will be target, do you want it as a new target? Target 51.
51, and it's 100 meters to port.
Thank you, Nav.
That's actually target 31. It should be the same. It's pretty much dead on. We'll drop another one anyway, but
Alright. Can I see the ping information, please? Done.
so can we compare that with 31, the photo?
It's an interesting shape.
Sorry, are you marking this as a, I can't hear you if you're,
Oh, I'm sorry.
there you go.
Alright, this one is going to be
Should be 52.
52, yes.
Still about 100 off, right? Yeah.
This one
80.
is about 80.
Okay.
Actually about 70.
Okay.
70 meters to port.
Yes, please.
That's 52.
Okay.
So that's probably part of the same feature, but we can get the extent of it then.
Are you? Oh, you're doing it.
So Dr. Megan, what stood out to you about this target?
Again, like all of the others, it just, things that pop out that look really weird.
It's like multiple layered shadows on this one.
Normally when we see
Semi-regular, yeah.
rocks, it looks, I mean, they make sometimes rectangular sort of shapes with rectangular shadows, but then this one, hold on, and I'll pull up the pictures after we're done.
Yeah, I'm done.
Okay.
I'm just
Okay.
trying to get a description down.
But I mean, it looks like we have a line of rocks in this area anyways, but so I'm going to pull up target, did we say 31?
31, I think, is that. Yeah, it may have
Yeah.
been 30 as well. I'm not
Yeah,
sure.
so 31 had these very strange shadows over here with more returns that just look kind of strange. And then 30 had, yeah, 30 was these things and this weird lines. And then the ones that we just picked up look just weird, and that's only a part of it. What we saw was a bit more elongated. But yeah, also some of these things and then a very long shape. It just looks kind of odd.
Around, yeah, all in the same area here.
I think this search is a great example for the layman of how difficult it is to find something even when you think you know approximately where it's located.
That's why you always email Lonnie, because she'll find it.
Yeah. Try finding them down there.
Can't even find my phone in the same room.
Yeah.
Well, that's I mean, essentially we're like looking over a 2 square mile area with a flashlight in pitch black.
Proverbial needle in the haystack.
That's right.
It's funny, Dr. Ballard did a show, I think on National Geographic, a series, and the demonstration he did of looking for something on the seafloor was literally to be in the woods out behind his house with a flashlight at night and showing that, you know, I know this forest is here, I know these woods are here, I know there's a whale house over there, but with just a flashlight,
Yeah.
it's very hard to find.
I think it was Alien Deep is
Thank
the
you.
series.
That's weird.
Yeah, these have been the most promising targets, I think, this area.
Yeah.
If we aren't finding anything that speaks to us more, this seems to be a good area. And we'll actually pass over this target again when we redo our line.
Oh, okay.
But if you're inclined to drop it, we can do it.
Why not?
Yeah.
Will we be close enough to potentially see it on the camera?
No.
Nope.
All right, this is
Womp
target
womp.
53.
Yeah.
53.
53. Actually, it's hard to say with the way USBL is. I don't want to say definitively no, we won't. 50. Target
53.
53, and it's 60 to port.
Eh,
It was 60 to port.
yeah.
Somewhere over here. Okay.
What do you want to save this as? Or description?
Large bulbous mass.
Um,
If you say it, I'm writing it down.
I don't know.
Bulbous mass it is.
Pretty much.
You're welcome, Internet.
Feel free to send in some questions to us. We're continuing our international trend. Picked up New Zealand, Canada, Australia. Thanks for watching. So Dr. Megan, in your studies of aviation archaeology, was there something that maybe you learned that stuck out to you the most as maybe the coolest or most surprising, or something that just stuck with you?
Um, I think that for me, so I've said it before, but I am a liberal arts major, and that's not exactly the most chemistry concentrated major that you've ever seen. So of course I did chemistry in high school and everything, but by the time that I got to graduate school, 13 years later, I was going on what I knew of archaeology, but when I was doing my PhD and looking at these aircraft sites underwater, one of the most striking things to me was looking at the deterioration and trying to find patterns in the deterioration that would let you know how maybe, say, other aircraft would deteriorate. So just trying to discover all of the ways in which site formation can happen no matter where you are and no matter what depth you are, what matter temperature you are, oxygen level, everything affects the way that an aircraft is going to deteriorate, and mostly the way the metals interact with each other and the salt water to form a galvanic cell. So being able to predict if an aircraft is going to have organics on it, like the fabric covered control surfaces still remain, whether or not it's going to have paint that's still visible on it, whether or not you'll see skin, a large amount of skin, or whether or not that'll be corroded out, large patches of corrosion. We were talking earlier on an earlier shift about the USS Macon site, which are biplanes made in 1933, and they sank in 1935, and you would think that there's no way that there would be anything left of those, but on those aircraft actually had aluminum structure, but fabric covered, large amounts of fabric covered surface, which we still see. And we still see paint that's very, very visible on those. The Macon biplanes had wooden propellers. I know that we've been asking about that for this aircraft, which does not, but the Macon did. Or sorry, not the Macon, the actual Sparrowhawk biplanes did. And those were still present on site, or one of them still was. And this was a site that was about 500 meters deep off the coast of California. And then on other sites, so I look at a B-29 that's off the coast of Tinian, and it is a later World War II B-29, so all metal surfaces, but we're missing the top layer of skin off of the entire airframe. So you can see the structure, all we had was structure underneath, and that whole skin structure had been scoured away, basically. But we still did find organics on that site as well. And on shallower sites, we find aircraft almost completely intact sometimes, but missing things like the paint and flight control surfaces and other sorts of issues, and had things growing on them, but not a lot. So, sorry, I guess to answer the question in a really roundabout way, I think what was the most surprising thing to me was being fascinated by the decomposition of these objects in salt water and actually in fresh water. I've had the opportunity to study some aircraft up in Lake Washington in Seattle area.
The one the guys dive inside. What is that?
They're
right off
actually
of, Sand Point?
Yeah, there are actually 9 aircraft in that lake. 4 of them are large Navy aircraft, and the corrosion that's going on there is completely different than what we'd see in salt water. So, yeah, just really interesting to me is the decomposition. Site formation over time. We studied the Macon site for the past 30 years, basically, 20, 30 years. And
12, 9.
I think that some of these sites that we have found now that are dive sites will be able to study into the future, taking corrosion potential readings at some of them, just being able to log the deterioration, human interaction, or environmental causes. We'll see.
That's kind of what forensic anthropologists do. They'll study decomposition in sea over time. We've done work. I don't know if we have. I've done work with those on other projects.
Right.
And they have like those farm that I think it's a single farm down in Florida or somewhere in the south, where they study that as well. It's almost like you need the same thing for aircraft. To, you know, every 5 years we're going to put a piece of this material in, and then we'll have a record of exactly what it's going to look like over time.
Right.
Under different circumstances. That's a pretty big project to bite off. And then especially as material sciences advances, you have, you know, aircraft now with composite wings and materials. Like the 787. I don't think there's any 787s operating in the Pacific, are there? Everybody get here on an A330?
I have no idea. I got here safely, and that was the most important thing.
I pointed out to my wife a long time ago when she was be nervous about flying, that you could go to like FlightAware or something, and there's something like 7,500 planes in the air. I think that might even just be like over the U.S. I mean, it's just a ridiculous amount at any point in time.
Yeah.
24 hours a day, all the time.
We're still going to the northwest. I thought we were coming west, but
My wife took a flight up to do
still coming around.
Detroit 2 days ago, and they actually had to turn around because they hit a bird.
Oh yeah.
Sucked a bird right into the engine.
When they manufacture the aircraft, they shoot birds through the windshields.
Yeah, that happens at Carnegie Mellon University,
I
think it's Carnegie.
I
talked with their
Riddle. What's
Embry-Riddle?
Embry-Riddle. Thank you. Maybe there.
I did a bird strike project with students at one point, and we ended up talking to them about bird strikes and the impact it had, and they take those like a frozen turkey, thaw it out, and then just launch it in an air cannon.
The thawing's a critical part of that process.
Yes. It was they talked about what happened to the birds when they do hit objects like that, and it was a pretty uncomfortable experience for them, but they don't suffer long. It was actually the lab at the Smithsonian, so whenever a bird hits a plane at an airport, they take the remnants, which is called snarge, and they send it off.
That's a made-up word.
And it's called snarge. There's a video about it, and you're gonna not believe me even more when I tell you the name of the doctor who is in charge of that. Her name is Dr. Dove.
Dr. Dove?
Dr. Dove.
Okay, I buy that.
Science Friday did a great video about it.
Snarge?
Snarge, yep.
All right.
They take the samples, they do
I know
DNA
I'm getting
testing.
suckered into Googling this word, but
That's all
I'm
right.
going to go ahead and hit search and see what happens.
And the little barbs.
All right, this says it's a word, but it's slang. The first result is from, here's a Wired article. Yeah. Smithsonian scientists call it.
Yep.
Yeah. Okay.
They
Your
take the
answers.
little barbs on the end of the downy parts of the feathers, and they're just kind of like fingerprints. And they can use those to identify the species of bird.
Wow. Snarge.
Snarge.